Hey, George here again. Before I go into the details of laser locking and show you the electronics, I wanted to just try and go over the details of how we side lock the laser. Right, so let me start with this picture. We have some signal that comes in from our photodiodes that goes up and down as I scan the frequency, or scan the piezo voltage. This could either be a saturated absorption feature, which is what I'm going to lock to, that has sharp features, or it could just be the regular Doppler broadened profile. And again, you could lock somewhere to the side of this profile, and I'm going to explain how that works. The first thing we want to do is to set some reference level, which I'm calling the V equals 0, somewhere along the side. And an interesting question is where along the side you want to put it. I'll talk a little bit about that when I'm setting it up then. But anyways, we pick some voltage along the center, we make that V equals 0 volts. And right, I'll get into the details of how that happens. Then we imagine somehow that the signal moves away. So let's say it goes up and I get a signal, the frequency somehow shifts and now I'm up here. Then that gives me error voltage, the difference between where I am and 0 volts. So I get some error voltage. And we gain that up and we modify it and things like that. And we send it back to the piezo voltage. So this is the piezo voltage modulation. Same comes back, goes back to the piezo voltage. This was a positive voltage then, and so that I give it a positive piezo voltage, and that tends to move this point that was up here back down to this point where we're trying to lock it to. I guess the point I want to make here is we can only lock on one side of these laser lines. And if you look on the other sides over here, you get sort of a positive feedback situation where if the signal goes up, I get a positive that with a more positive voltage and it just can't lock to these sides at all. If you do for some reason want to lock to the other side of your signal, the only thing to do then is then to flip the whole thing over, and you can do that by choosing which side, if it's a single photodetector, which side to hit the photodiodes on. PDs are supposed to be photodiodes here. Or you could switch the polarity of those and switch your whole spectrum over, and then you can lock on the other side. So yeah, now then just quickly through the electronics here. There's our gain stage with our two photodiodes and balances that we do. There's a low pass filter, which I'll talk about in a minute. Then there's a final gain stage which has an offset in it. And that offset can go from -5 volts to +5 volts. So that means that the range you're signaling here has to be 0 to 5 volts. You're not going to be able to find this V equals 0 point on there. So anyways, that gives you an offset. You can then look at your signal and adjust it so that whatever point you're locking to is at 0 volts. I'll show you all that. We put it into the piezo controller and then turn this, there's an attenuator, and turn this up to max. Well, that's where I run it. It depends. You won't always be able to go to max. It depends on how you set your other parameters in here and stuff. But anyways, that's where I do it. The low pass filter. It turns out if we give too much gain, there's an oscillation in this system that happens at about 3 kilohertz, and I'll show you that too. And so what I want is I want to roll off the gain at high frequency, but I want to have lots of gain at low frequency so that if there's thermal drifts and things, the system can sort of stay locked there. But right, it doesn't oscillate. So there's a single pole filter time constant in there. Single pole, only a 90-degree phase shift. 90-degree phase shift. Yeah, if there was multiple poles, you'd have 100 degrees and you'd make an oscillator even easier. And then finally, I put some typical numbers in that I have for gains around the system. And the initial stage, this is for saturated absorption side locking. I typically have a gain of 5 there. I turn the low pass time constant up to its maximum value. The gain here is very small, and we'll get oscillations if we crank this up too much. So 1 or 2 are the low range, and the piezo I always run up to maximum. Okay, I'm back here. I've got a saturated absorption signal with a piezo only scan on here. Yeah, and I'm gonna zoom in and lock at one of these, one of those laser features. So the first thing I want to do is move that over. So that point's going to be sort of in the middle of my trace there. We'll see, and when I expand that scale, I want this region to stay in the center. And I'm going to subtract out my background signal, gain it all up. That's a gain of 5. Let's increase that and zoom it out a little bit. And now I'm going to reduce the scan rate so I get, let's keep this big a little bit. Reduce the scan rate while I keep that in the center of my screen there. And that's sort of good enough. And now I want to switch the scope from doing a time display to doing, put the scope in XY mode. So I'm going to put channel 1, which is the monitor from the piezo at, it's just adjusting that. That's going to be the x-axis, and the output of my photodetectors and things is going to be my y-axis. And at the moment I'm still looking at the monitor here. I have the time constant down to 0, so I'll switch that over later. But let's first go to XY mode. And to do that, display XY. I want to have both of these signals in the center of the screen, so I want to adjust both offsets so that the 0, 0 point is right in the center. And I just sort of unhook things to do that. Then you get a point down there that tells you when you're there. Okay, there we are. So there's XY mode, and in general, I've got some offset on the x-axis because I'm only sweeping a little bit and my piezo is way out there. So there's a monitor offset here on the piezo controller, and that goes from 0 to 5 volts. So you can only offset 5 volts, but I can use that to bring the signal back into the center. If you've got your piezo controller more than 5 volts, so it's possible up to 10 volts, then you're just going to have to go over and find the next mode and lock onto the next mode of your laser there. Okay, so now I've centered that onto 5 volts, and now I can expand the x-axis scale. One thing I need to tell you is all the features have now gotten mirror image. They've gotten reversed I used to do a time sweep going through the signals with a decreasing piezo voltage. Now I'm doing an increasing voltage positive, so all these signals get flipped around. Hopefully that won't be too confusing to you. So here we are going through that. Let's just slow that sweep down a little bit so we can see it. And I'm going to turn the persistence on so we can see those features. So this is this spectrum has been flipped around from the way we normally see it. And you can also see some hysteresis here, that the signal doesn't always fall right back on the same trace. Okay, now I want to adjust the offset for the side I want to go on here. So first of all let's just turn the sweep off and put the persistence up to infinite. And now you can actually sweep through this by hand just with the piezo controller and see how good you do. There we are, and we leave it right there. It's sort of parked right there in frequency. Okay, so now I'm going to take my output from after this offset voltage here, and let me sweep through this feature again. So now as I move this, I can move this point up and down. And let's expand the scale a little more to see what we are here. So there we are, and I've got 0 volts set at this line, so I've got to move my whole system down a little bit to get it to lock. So there we are going through it. And where to lock on this signal. I guess I'll talk a little bit about that later. I'm not going to do it right now, but I'll talk about it now. If you lock right near the top there, it's not going to be very stable because a tiny bit of motion and it goes over the edge, you've sort of lost your lock. so it's in a sense more stable to lock down near the bottom. A disadvantage with locking at the bottom is that if there's any DC offset, you can sort of lose where 0 volts is. So anyways, okay, here we are. I got the laser part, it's at the bottom. Oh, you can see when I'm talking I get lots of vibration in there, and that's probably going to screw up our lock some. I'm just talking close to it. So now I've got my offset set. I'm going to increase my time constant. I'm just going to crank it all the way up and not play around with what's going on in the middle. And now I want to take the same signal that's going to channel 2 and feed it into the modulation input of the piezo, and we'll see what happens. And as I said, if I talk, you may lose lock here, so I don't know, I'll try and talk quietly or something. So there we are again. Oh, yeah, the other thing I should say is there's a fine control on this piezo voltage, so you may find it useful to sort of set that in the middle of its range and put the piezo down to where you want to lock. Oh, and now it's, yeah, you'll notice it's a lot slower. If I go through this signal too fast, it doesn't come at all. So anyways, so there I am. I'm just going to erase the screen again so you can see it. So here we are. Boink. And now I'm going to turn up the attenuator, and this should try and lock it. Stop bouncing around. Should try and lock it right there. And it drove that point right to there. The laser is now locked. That's sort of easy. Let me expand it here and show you a little bit. So I'm cranking up the gain, and if I so I'm vibrating the table there by banging on it, and you can see I'm staying in lock there. Okay, the final thing I want to show you is turning up the gain even more. Sort of how much gain do you want in the system? And my answer is as much as possible until it starts to oscillate. And if you turn up this, so these numbers all sort of work, a gain of 5, and this guy's all the way up. And this one is now at 1. And you can actually hear the piezo oscillating very quietly, but there's air conditioning and my talking, and we're not going to be able to hear that. But what I want to do is put this back into Y as a function of time mode, so time, and let's get this, hang on, trigger menu, auto. So now we're scanning, and I'm looking at channel 1. I'm going to move down, that's the piezo voltage. Channel 2 is the photodiode signal, and I'm going to turn up the, oh, did I lose lock? No, it's still there. I'm going to turn up the, let's turn persistence off, hang on a minute. Display off. Okay, and I want to increase the time base a little. It keeps triggering some. I'll turn that off. Okay, and now so there it is. So I'm increasing the final gain stage here and looking at the output. And yeah, let me expand this a little more even. And that's the piezo. And we can see as I increase it, yeah, I'm talking and it's sort of modulating all that. I start to get this 3 kilohertz on top of there. And that's sort of bad. It's now the laser is wiggling around and stuff. So you want to have less gain than that, as much as you can, but just below where that starts to occur. And so that's sort of fine. I got the gain at sort of 2 or something. Let me go back to the X, Y mode, get these.